All right, looks like we slowed down. People coming in. So we'll go and get started. Just for the sake of time, this is a new presentation. You never know how long they're going to take. My name is Troy Daniels. For those of you who have not taken one of my trainings, I'm going to be talking today in a little bit of detail here regarding some of the things that we see can cause issues with installations, whether that's improper sizing, improper programming, various different methods of design and installation that we see do cause problems, and the ways to avoid those problems, and what can happen if you do decide to ignore those kind of guidelines, warranties, spec sheets, integration guides, all the material readily available. A little bit of housekeeping. So if you do have any questions throughout the presentation, go ahead and just shoot it into the Q&A there. So if you go up to your little top control bar, click Q&A, you can type in any questions there. I'm gonna go ahead and open my door a little bit here to see if we can get less echo. There we go. All right. So we'll jump right in. All right, so just a company overview. I really like to do this on every presentation in case somebody's here that doesn't know much about our company. So we were actually started in 2010 as OES Energy. This was the original name of the company. 2011 and 2012 picked up a lot of residential and even military projects, which really kind of helped drive our product development, building more and more both batteries and as well as ESS solutions, so energy storage solutions, more all-in-ones as well. We actually relaunched the SimpliPhi Power in 2015, 2016, which made a lot of sense as, since now we've moved out of OHI, so we are no longer would make sense to be OHI Energy Solutions. And since then, we've just been ramping up manufacturing, growing our distribution network, and just trying to innovate as much as we can on the current products that we have. Okay, so kind of looking at our company as a whole, what we do is safe, proven, and simple technology. Safe, as it is cobalt-free chemistry. For those that don't know, that is really the main driver to thermal runaway, which is a really big, hit story on the news and things like that. And we don't manufacture with cobalt. So basically, no risk of thermal runaway. UL certified 1642. 1973, so 1642 on the cell level, 1973 on a battery level, and 9540A on a system level, which is going to become more and more common these days, that you're going to be seeing that as a requirement soon. UN DOT certified as well, 3480, 38.3. And we are actually SCHIP approved for those that are in California. Proven technology, over a decade of experience and growth, 100 megawatt hours installed in 40 various countries. That's continuing to grow, probably outdated already. I actually haven't updated that figure in a while, so we'll take a look at that and see where we're at now. Tested and validated even by the US Army and Marine Corps. And we're actually manufactured here in the United States, so in California. Excuse me, jumped out a little bit there. There it goes. Okay. And very last, simple technology. So simple, we are really trying to integrate with any generation source you may have. We're trying to make a product that is easy to use, whether it's an advanced comms battery or just our simple standard battery. We want a product that fits every need and every expertise level, I guess you could say. So whether it's going with an all-in-one system because you've never done battery-based systems before, or you've been doing this for years and years and just want the batteries themselves. So again, we do not use cobalt. Our chemistry is lithium iron phosphate with a cylindrical form factor. This is where all of our safety comes from. In just speaking a little bit before this presentation, looking at how these cells perform even without a battery management system. We're going to talk about this today, but seeing the safety of these cells, even during extreme failures where they are being pushed well outside of their boundaries of what they should be operating in, these cells are safe. I want to do a little plug here, actually. So next week, our other technical trainer, Matthew Walker, will be doing a safety and standard training. I definitely, if you haven't signed up already, jump in there. It's going to be a really great training, touching a lot on the safety of the batteries, the standards they're held to, the testing they go through, and it's really going to give some really good insight that puts our battery and our chemistry, as well as, again, our battery compared to other batteries that might use our chemistry, the same chemistry, I should say, against others, and really kind of see how they stand up. So I would definitely recommend signing up for that presentation if you haven't already. It's on our website under trainings. So again, here you see lithium iron phosphate versus the cobalt-based batteries, no chance of thermal runaway, non-toxic, does not involve abusive mining practices, which is typically derived from the cobalt, where the abusive mining practices. Again, we're going to be going actually into that in a little bit more detail next week, so definitely check that out. We don't require big cooling systems, safety monitoring equipment, and we can actually withstand higher temperatures. Okay, so now to get to the kind of bulk of the presentation here, the do's, the don'ts, what will happen if you do, kind of ignore what we would have put forward. I'm going to just preface this whole presentation by saying, there's tons of resources, and we're going to talk actually a bit about that. Tons and tons of resources that are available for installing, for designing. Our team's available. We want people to call us, go through designs, call our pre-sales line, call our support line, touch base. We need to kind of, we're happy to look things over, but if you read the manual, if you read the integration guides, you talk to us, you can't mess up. So definitely homework is kind of everyone's best friend, especially if you have never done this. Even if you maybe have done it like 3 times successfully, look it over a few times. You might have something you missed that didn't cause a problem the first few times, but could lead to a problem later. So first, we're going to be talking about over discharge. Now, I kind of put these in order of what's the biggest issues I see as far as how people destroy either damage or destroy their batteries in order. And I'm kind of pulling out the 3 biggest things that I see happen. Over discharge being the number one thing that people do to damage the battery. You got a nice little picture here of a Radian 8000. It's an 8,000 watt continuous inverter with 2 SimpliPhi 3.8 batteries. We're going to talk about why that is a no, why you would not want to do that in a bit here. So over discharge can be caused by several conditions, but they're all related to the exceeding of either the max continuous discharge of the battery and the max discharge at 10 minutes of the battery. It's got to be one of those things. So that's really where I think there's a misconception. We'll talk in a second here about our sizing requirements, inverter to battery, but those requirements have less to do with the inverter size than what has to do with what we would make sure, or what we would do to ensure that there's no chance of over discharge. So again, these batteries have limits. That's kind of what I'm going into on the next section is, warranty spec sheets, all of these things, integration guides, installation manuals. We've got sizing tools we'll go into in a bit here. And even on the battery themselves, there's a placard that calls out the specific max discharge and max continuous discharge per battery. You can't miss it. It's very obvious. I think it's even called out in DC amps and kilowatts. So there's no way to ignore it. People still find a way to ignore it. I don't know how, but I think it comes down to a lot of maybe customers saying, I promise I only have 200 watts of load. And then you put in the system as an installer and you come back, you oversize that inverter, you come back and this customer has added loads on and started pulling more power without telling you, and they've over discharged their batteries. So what's the easiest way as an installer to protect yourself from that? Really, really simple. Size it correctly. The 2-to-1 ratio, we call it out in all of our documentation. It's the easiest one to follow. If you've got this 8,000 watt inverter here on the right, don't have 2 batteries like it's shown there. That is the incorrect. We want 4 of these batteries because we would want 16 kilowatt hours of storage. 4 is actually a little bit undersized. Really, we want 5 now that I'm thinking about it. So, you know, there are some expectations where things are going to be slightly undersized, and you're still running the risk. I'm going to say that right now. You're still running the risk of possible over discharge. But if you just follow the 2-to-1 ratio, so 8 kilowatts, double that on the kilowatt hour capacity of the battery, there's no chance, even if your customer starts adding on hot tubs and who knows what else, they cannot over discharge the battery. It's really a safety mechanism put into place for you as the installer to know that your customer has no chance of damaging their battery. Now, our newest addition to our battery line, our SimpliPhi battery, those have checked it out before. And I just want to, I want to stop and preface, if you've never taken any of my other trainings, as kind of stated in the description of this training, we're not really going to be talking a lot about specific products and things like that and product overviews. That's kind of our standard training. This is really, again, more for the specific topic. So if you're not familiar with our products or anything and want that kind of information, tons of different trainings on our YouTube channel under trainings to find that, as well as upcoming trainings that we'll be doing live. Okay, back to the SimpliPhi battery. So those who know it, our newest battery has closed loop communications built into it, meaning it can communicate directly with the inverter from the battery management system, from the BMS. This actually allows us to work on flexible sizing. So this 2-to-1 ratio is not as important when hooked up to an inverter that it communicates with. So for instance, the SimpliPhi right now talks to the solar inverter. You can have a single 3.8 battery hooked up to a solar because we know that the battery is what's telling the inverter to ramp down. Now, most inverters, a lot of inverters, I should say, don't even have the ability to ramp their discharge down. But the solar does. That's why we integrated with it, with the SimpliPhi. So you can have flexible sizing. So if you do have a customer that just wants that big 12K inverter for some reason and only wants 2 batteries for the time being, then I would go with our SimpliPhi battery because you can, it will communicate these values, hey, I can only do, you know, my max continuous to go back is, you know, 37.5. So I know per battery, I have to add those together, tell the inverter not to do that. So again, really easy when it comes to that. You know, and if I go back here, I didn't actually call out the specific spec. And the reason for that is we have various products. And I really think it's important to always just look at the warranty, look at the manual, look at the spec sheet. You'll find the value you're looking for. And it's really important to kind of know how to navigate those tools. As if things change, you still know how to navigate those tools. If a new battery comes out, you know how to find that value. Beyond that, we've got tons of battery sizing tools on our website. I'll talk about that in the next slide, so we'll kind of pause there. But we do have a lot of tools that can help for kind of making sure you're sizing correctly. As I mentioned already, call us. We're happy to double check your sizing. So call our pre-sales, call our tech support. Let's double check things. And a little side note here regarding over discharging and AC coupling. I see it a lot where maybe a customer has more PV than they actually want for backup, and they will over discharge. They're not using their batteries very often. They throw a lot of loads on. They don't know what to expect. Over discharge seems to happen way more often on an AC coupled system that's used for backup than it does on like an off-grid system, because you're sizing it for maybe a few hours of backup possibly. Hopefully you're sizing it for longer than that, but there's a lot more situations where you are sizing it like that. That's where I see a lot of over discharge. So again, we've got numerous tools, tons of different tools that can help with system design. Pre-sales support and system design confirming, so make sure to call or email us and talk through sizing requirements and guidelines. We're happy to help. We do have battery sizing tools based on load, but more important for what we're talking about now is the battery sizing tool based on system design. So I won't go into it too much here. Let me see if I can actually pull that out. There we go. But this calculator is actually designed that you can type in values. Sorry, here, I'll jump past it. My internet's running a bit slow. Typically, it would load up here. Let me try it one more time. Well, I don't want to slow my internet too much here, but you know, keep in mind that right here is our tool, and it basically takes into effect inverter size, charging size, various things like that that can really, really help. There we go. It took a second, but so you can even say AC DC coupling. You can type in your charger size, your inverter size, and it will help you determine if you are incorrectly sizing by any means. Okay. So over discharge is not covered under our SimpliPhi warranty. This is out of spec. This is something that you have to mess up on. This is not something we'd expect the batteries to go under, so it's not covered under warranty. Over discharge, as I mentioned, will not occur if the system is sized properly. Physically impossible. If something happens that looks like over discharge, it can't be. So we need to double check what's going on, what could have failed, what the problem is. Some signs of over discharge include low cell voltage. When I say low, I mean like 0 or 8 volts. Not always a sign. You'll see later that's a sign of other things as well. A lot of these kind of coincide. So you might have a lot of questions coming from our support. If you do mess something up, it's because we're trying to do some investigation here. Battery management system disconnects. So that's an internal. It's not the external circuit you see on top of the battery. That will typically show really low voltage. So 0, 8, like I mentioned, that's a sign that the BMS is open circuited. Breaker flip on the battery bank, that's almost always a sign of over discharge or overcharge, because that means that physically more than the allotted current from the breaker was put through or out of the battery. Or the battery will not hold a charge when load is applied. That can be a sign that you've over discharged and damaged your battery. Under very severe circumstances, the internal wiring and components can see excessive heat. I've seen some scorch marks on things. Again, the cells themselves, even in these situations, stay safe. That's why we love lithium iron phosphate, safe chemistry. It might be something like you push the battery so far out of its limits that just the wires burn up, that we're connecting the battery management system. So that's a clear sign, definitely, of something like an over discharge. All right. So second, I would say, second biggest factor for what I would say is the likeliness of somebody messing up their battery, performing out of spec, is low battery voltage. I'm going to read this a little bit. I'm sorry if I'm kind of reading right off the slide, but I think this is really well put out here. SimpliPhi batteries are designed for 100% depth of discharge. Typically, this can be measured by a voltage during discharge conditions. The SimpliPhi batteries are not designed to operate below 100% depth of discharge, and it can often cause damage if repeatedly dropped to a lower voltage than that 100% depth of discharge. Okay, so this is where a lot of confusion comes from. And a lot of confusion definitely comes from homeowners on this one. Do-it-yourself people are my number ones as far as what I've seen that mess this up. Somebody that's never worked with batteries before tends to mess this up. The common misconception being that 100% depth of discharge means 0 volts. There's no way. 0 volts is well below 100% depth of discharge. Batteries have voltage range. They each are a bit unique. Even some lithium iron phosphate batteries to battery might have different voltage ranges from 0 to 100. But ours, if we're talking 48 volt, is about 48.0 to 53.3 is 100% resting state of charge. You charge higher than that. I know somebody might be panicking saying, oh, I set my charger way higher than that. You do charge higher than that. That's just resting state of charge. So again, typically the battery is 0% state of charge, or SOC, at 100% depth of discharge. So I see, hey, I just want to mention, I see a question. Can you just put a little footnote? It says, wouldn't this be controlled by? And there's a question there. Would you just make sure to write what you're talking about? Because I'll answer all the questions at the end and I might forget, well, what slide we were on at that point. I do appreciate it. So again, 100% depth of discharge at 48.0 on a 48 volt battery, 24.0 on a 24 volt battery, and 12.0 on a 12 volt battery. This can be really confusing because it's quite literally what we would expect the nominal capacity to be. First and foremost, 48.0 is not the nominal capacity of our batteries. 51.2 is. That's the big kicker oftentimes, is 48.0 correlates with 0% state of charge, and a lot of people miss that. Now, a big point, this is a point for everything, the battery management system does have internal disconnects, it does have protections, but it is not something you can just rely upon. If you discharge too many times below that point and ignore programming, you're going to see damage. The battery management system cannot handle trying to save the battery over and over from an improperly programmed system or an improperly designed system. That is not its function. The cells are very resilient and can hold up to a lot of damage, I promise you. I've seen people discharge their batteries well below 0, way down there, maybe even multiple times, maybe even years of it, and we can still recover the battery. It's just not a guarantee. So how do we mitigate this? How do we make sure that we don't disconnect? Low battery cutout, LBCO, can be programmed to be used to ensure the battery voltage stays within the specified range. Low battery cutout is just a setting. It's actually in the inverter. That's where the setting typically lies. That can basically put the system into standby so the battery can accept a charge, but it cannot discharge any lower. So you set your low battery cutout, let's say at 48.0. Now you've ensured that your battery will not discharge below that 0% state of charge. It also helps us prevent any manual reset of the battery, which if you see the the battery open circuit, not the physical breaker, but the BMS goes in open circuit, you lose voltage, you have to manually intervene. Programming correctly, you'll never have to do that. So it is, again, programmable on most inverters, but it is also important to check the inverter's range. Some older inverters, some inverters that might not have lithium in mind, might not be able to hit the target voltage we want. So if you come across an inverter that has a low battery cutout and the highest it'll go is 38 volts, or let's say 44 volts, I see that one a lot on older or maybe lead acid based inverters, you can't use it with our battery to be the low battery cutout because it cannot go high enough to hit the proper set point. So a little another note here, SimpliPhi does have some more protection built into our newest comms battery because it actually auto-populates the setting in SOC-based disconnect. Again, only with inverters it's speaking with. So right now the SolarC's the one that it speaks with. So it will automatically say, hey, I'm going to tell you what my state of charge is, and then it will never let it go below 0. Just internally in the inverter, it would never let it go below 0. Because it's reporting its state of charge correctly, it won't go below 0. Now, low battery disconnects are sold as standalone products. You can see on the right here, this Victron this is a Victron low battery disconnect. This is my go-to typically when I go with a low battery disconnect that's external. You can see here 12 to 24 volt, and it does, I believe, have a 48 volt model as well. This is just designed to perform that low function, that disconnecting function. Now, the most important time to use one of these is if you have DC loads, even if you have an inverter. This part's really tricky for people. I see a lot of systems where they have an inverter, they program the low battery cutout, but they also have DC loads direct coming from the battery. They're pulling maybe lights that are DC, and but they're not understanding is the inverter might go into that low battery disconnect, but those DC loads are still pulling from the battery below that 0%, nothing to protect them. Until it gets that BMS shut off. And at that point, they discharge pretty low. We really don't want that to happen. This is where we can use the external, the standalone low battery cutout. So anytime you have DC loads, this is a key item to put into your system. Okay, so what damage would you expect to see from excessively low voltage discharge? And is it covered under warranty? Not covered under warranty. If you're going to over discharge too many times below our range, our low battery cutout expectation, you can see damage that might occur outside of warranty. I'm going to say that this is much less apparent than over discharge. It's more forgiving. I've seen people draw their batteries below that 0 plenty of times and still be able to function, get those batteries back up. It's if you catch it early that, hey, I forgot to program that setting, oftentimes it's not a problem at all. It's excessive use. So it's where you've just done it over and over and over again. That's where it's really frustrating. So settings for low battery cutout and voltage ranges can be found throughout all of our documentation, integration guide, installation manual, and warranty. You can find that set point. It's one of the most key set points, I think, when you're programming a system beyond charging limits. So definitely look around in that one. If the battery hits internal BMS cutoff, so below that 0% charge, it often can be recovered, but may require an external charger. You might not be able to use your inverter charger or your charge controller because they can't turn on now. The battery is too low. So in those cases, it's a bit frustrating. You might need to go out and buy another charger just to charge that battery up and get it operating again. Again, if you do everything to spec, you program correctly, there's no way this is going to happen. That's the great part about it. So just follow the guide. You won't have the issues. In some cases, battery will exhibit extremely low voltage and can no longer hold a charge, a voltage, and the circuit will not engage in these situations. That is, again, the most extreme conditions. But if it does happen, then you damaged your battery. So it's just important. I'm going to harp on this the whole time. Just read the manual, read the integration guide before you do any programming, before you do any installation. And if you have any questions, we're on site, we're on hand to talk you through the site visit. Set it up with us, give us a call while you're there. If it's during our operating hours, we're there. We're going to talk to you. We're going to help you out. Make sure those set points are correct. Okay. See how we're doing on time here? Perfect. All right. So the last one I'm going to talk about as the big three that I mentioned is overcharging your battery. Now, first and foremost, overcharging does not mean, hey, I'm floating the battery all day. That's not overcharging the battery. It typically means to excessive voltage is what I see as far as damage inducing overcharging most of the time. Overcharge can cause the battery damage, which is similar to the damage experienced by discharge. They're very similar. Now I want to emphasize again, this might be cell damage or wire internal component damage. But again, this is way outside of spec. This is way outside of what they're supposed to be operating at. And even then, the safety of the cells will ensure that no, that we cut down on chances of really dangerous situations, which you'll see with like cobalt-based batteries that go into overcharge and they catch on fire. That's the simple truth. Those kind of cobalt-based lithiums, when they see these kind of issues, see a lot of dangers. And again, we're going to be talking a lot about that next week, so I encourage you to join that presentation. So, depending on the charging type and the system design, it is often super easy. This is one of the most easy ones to avoid. If it's a DC coupled system, so you're using a charge controller, you're DC coupled, it's really easy to avoid this. We can actually program the system to not overcharge. Charge controllers are really good about clipping. They know how to take a large PV array and clip. They have their own limits too. You probably don't want to stick a double the size PV array on a single charge controller. You might see a lot of issues that way. But they can take a larger, like let's say you're up in Montana, maybe let's actually go higher. Let's go say you're up in Alaska. And there's times where you don't get a lot of sunlight and it very well only peaks over that horizon. You need a large array now. But there's certain times where you don't need that large of array and it might be too much. Charge controllers are really easy to program. You can set that charging limit. Again, you can find those limits on the battery themselves. They're even printed on the limit. And they're in DC amps. So if you're plugging a charge controller in and you know that you only have 2 batteries, you can look on the placard and it says 37.5 amps per battery. Times that times 2, program that into your max charge on your charge controller. Now you're not going to overcharge. Now I will say, if something fails, like the charge controller, does not happen very often, but if somehow a safety mechanism fails in the charge controller and that PV array gets through, that is unfortunate, but it does not happen. Most charge controllers do not have that issue and have safeties put into place to avoid that. AC coupling is a bit trickier. If you've ever taken my AC coupling webinar, you probably know all about this, where I talk about that you kind of got to follow that same sizing guideline, that 2-to-1 ratio. So AC coupled systems rely on frequency shifting to curtail the PV. While this can limit the charging, it should not be relied upon. It's still, I'm seeing a lot of glitches, a lot of bugs where it does not properly curtail. So if you've got, let's say, a 10 kilowatt PV array and your batteries can only handle 9 kilowatts of PV as a max charge, it might curtail where it's always going to put out 9, but if that fails, which we have seen it not necessarily fail, it just doesn't function because maybe it doesn't match up perfectly with the grid tied inverters that were put in 10 years ago or whatever it may be, you can over discharge your battery that way. So it's important, if you're AC couple, if you're retrofitting, go ahead and follow that guideline, that 2-to-1 ratio. So just make sure that your batteries, if you have, 8, let's say you have 6 kilowatts of PV, just make sure you have 12 kilowatt hours of battery in case the entire PV array dumps into that battery. Problem solved. Overcharge is not covered under warranty. Again, these big 3 ones are things that are neglect of programming, of design, of reading through the manual, and they are not covered under the warranty because they are not within the spec of the battery. I just want to emphasize something too. This is not just something that would affect our batteries or our battery chemistry. It affects all chemistries. It affects all batteries, all battery types. If it was a lead acid and you overcharge, you're still going to cause damage. Still not going to be covered under warranty. I can't think of one battery company that would cover that kind of situation. So it's just important to understand it's just if you design, if you program properly, ask the questions that, you might have a question. Don't hesitate to call us and ask. We're here to help and make sure that things go well. These are easy to follow guidelines, and when done right, you're never going to have any problems. You're going to have happy customers all the time. So what are the signs of overcharge? Pretty much the exact same as over discharge, with maybe one expectation or one difference. Low cell voltage, this can be a sign that you've overcharged your batteries. You might have hurt something, either the BMS or the cells. The battery management system will disconnect oftentimes. The breaker will flip again because you put too much current in. And the battery might not hold a charge when load is applied. The only difference between overcharge and over discharge that you might see is a high cell voltage reading. So if you pull out your multimeter, you're having some issues with the battery and you're reading, 60 something volts, then somehow you put way too much either current voltage or power in general into the battery. And again, under severe circumstances, the battery internal wiring and components can see excessive heat. All right, a bit of a doom and gloom, but I think really, again, the point to bring home is, we have the resources to make sure these things never happen. If you follow all the guidelines, there's no chance it will happen. Other types of damage that are maybe notable, these are much less frequent than the three I just mentioned, but water damage and environmental damage, it does happen. These are not NEMA 3R batteries. We have a NEMA 3R enclosure that they go into, but don't leave your batteries outside in the rain or anything like that. Reverse polarity, believe it or not, I've seen it. I've seen it not cause an issue where they got lucky, and I've also seen it cause an issue. So just double check before you put your leads on there. Improper wiring and imbalance of system can cause an issue too. So you're not wiring correctly, and the way the power or the flow of energy and the flow of power is very off and can cause imbalances over time. And low and high temperature charging. That's probably the least frequent I see, but it does happen if somebody tries to maybe charge their battery at a really extremely low temperature outside of our spec'd temperature range. So again, these are way less likely, but they do happen. You can actually see here on the right, this is a real battery with water damage here. So this is water damage, where a customer did not check with the area that the battery was in, and you can see it's rusted and water has gotten into the battery, caused damage. So technical support and battery damage root cause analysis. It's a bit of a mouthful, I know, but I promise it's important. Technical support should be contacted immediately if your battery is experiencing any of the mentioned signs in all three of those different situations. Just to kind of go back through it, if you see your BMS disconnect, you're seeing a low voltage, you're seeing the breakers are flipping, it's not holding the load, let us know right away. We can take a look. We're going to ask you a lot of questions. We're going to really try to get to the root of the cause, but we're just trying to do our due diligence to figure out what's going on in the system. A lot of the time, the battery is recoverable if the damaging circumstances does not continue unchanged. So what I mean by that is if you pump in too much current or you're pumping out too much current and you notice the breaker's flipping, customer says, hey, my breaker's flipping, you as the installer jump on it that day, or say, hey, don't operate your system right now, let's just call it SimpliPhi. Oftentimes the BMS has helped protect the battery enough to the point where we are not going to see serious damage. We're okay, we can jump on, get everything fixed up, figure out where the source of the problem is on the design or the installation, fix that, and move along without damage. So time is always good. Don't let the customer, if the customer's experiencing some strange issue, if you can get them to disconnect the battery as far as not operating, so not discharging, not charging, whatever it may be, it's really key in most situations. But our support's there to help. Call our number, option 1 there, 805-640-6700, option number 1, get you through to our support. I promise, I know every single one of them. They know what they're doing. They know inverters, they know charge controllers, they know arrays, they know, how all these interoperabilities work. And they might ask you a lot of questions, but they're just trying to get to the cause of it. They've seen these, they know how to deal with them. They have also seen a lot of situations maybe where a customer thinks it's something that's wrong, and it's not. So that does come up a lot too. You can also email us at techsupport@simpliphipower.com. Okay, what is an RCA? RCA is root cause analysis. This is something we perform on the batteries if they do get into a situation where maybe they're seeing damage. And it's really hard for us to determine. The customer maybe doesn't, maybe even as the installer, you're saying, I don't think I did anything wrong. We can get the battery back and double check. And if there's nothing wrong, we don't see that you did anything wrong. Of course, it's within warranty and it's easy to replace. But sometimes we do ask that an RCA is performed. And it's really important that you ship it back in the proper condition. So this includes proper packaging that can be provided by us. So we can always provide that packaging to help make sure that you are not seeing the battery damaged on the way to be examined. You can use the existing packaging if you already have it lying around. That's always a helpful tool. This one is definitely important. Avoid weather, such as water damage to the battery. And what I mean by that is, I don't mean when it's operating. I mean, if you are having an issue with your battery and you want to send it back for root cause analysis, don't pull it out, put it outside, and then ship it back to us and say, hey, I think the battery might have been over discharging, or I think there was an internal issue going on. Well, now all we see is water damage. So the RCA is not applicable. You need to avoid, the battery should be returned. It says right there, the best phrase you could say, the battery should be returned to SimpliPhi in the same condition it was operating in, or else the RCA might not be able to be performed in a proper manner. Some figures to reassure all of this here. RMAs, so that's return material authorization. So people having issues, and I mean this in both if the battery was having an issue internally caused by manufacturing, or if, again, all these things that we talked about where it's neglect on installation, design, programming, whatever it is, made up less than 0.1% of all batteries sold in 2019. I think that number, I'm getting that number together actually now, I believe, is even lower this year. So that's a very small fraction of the batteries. And of that 0.1%, only 0.1% of 0.1% were actually manufacturer defects. So minimal. I mean, we're, a handful of batteries we're talking about here. So rest assured, it is very rare. And even these design and integration problems are not as prevalent as we might expect, but we just need to make sure that we're not that 0.1%, that we're programming properly, that we're designing properly. If we have questions, we're calling SimpliPhi, we're asking, hey, SimpliPhi, I don't think, I'm concerned maybe I didn't program this exactly right. We don't mind sitting on the phone and walking through it. I would also recommend, if you're installing our batteries very often, while it's not a requirement, join our IQ program. Pop this page open here. This program here, maybe not. Let's see if it works here. That's okay. Won't go to the page right now for some reason, but just know that the IQ program is designed to not only boost your business by giving you a nice spot on this where to buy map and showing that you're an installer that does install our batteries and we trust to install our batteries, but it also gives you the ability to know that you've gone through various trainings and testings to make sure that you understand these limits, these installation guidelines. It's really helpful. It's a really helpful kind of tool. So go to our page, go under support, go to installer qualifications. That's where I was trying to go to right now. And you'll actually see an application at the bottom of that page. Fill out that application. We're trying to get more IQ installers. I'm telling you, it's a really good program, not just to boost your business, but to really make sure you know what you're doing when you're on the ground and you have happy customers. Okay. If you have any questions on the training itself, training at SimpliPhiPower.com. You can always use our sales lines as well as our tech support line if you've got any questions there. I'm going to go ahead and pop open the Q&A. If you still have questions that you haven't asked yet, go ahead and type them into that Q&A section right now. We'll try to get through all these questions. What sort of efficiencies are we looking at? So as far as the battery goes, at 98% efficiency, actually. That will be a little stifled by the inverter. So I think about 95 or 96.5 is like the higher end I've seen, is what you're going to get out after it's been inverted. But still much higher than you'd see with like a lead acid battery. When using SimpliPhi batteries, how do you best manage the state of charge using LFP, or since LFP maintains such a steady voltage until discharge? Yeah, it really needs to be discharging to see that state of charge. Now, again, the best way to make sure that your state of charge is reading correctly is to use our SimpliPhi battery, because it's reporting directly from the battery management system to the inverter. If that's not an option, I would always say first and foremost, do not use state of charge based set points unless you're using our SimpliPhi battery. Use voltage set points. That's how our guides are set up. They're much more efficient and they're much more accurate. If you're just trying to get a reading as far as a battery monitor, I showed the Victron disconnect. Victron actually also makes a BMV 700 monitor. It's definitely the most accurate I've seen when it comes to lithium iron phosphate batteries. Okay, so I see the question regarding wouldn't this be controlled by the charge controller, was in regards to depth of discharge. So no, charge controllers do not have that function, at least none I know of. It's always in the inverter to do that function. Have an inverter with 48.4, low battery cutout as the highest it goes. The backup generator will kick on at 50.8, so not normally an issue. But what if the generator fails to start? Will 48.4 be fine for a cutoff? What is the state of charge likely to be at? And finally, if it's sat for a few days at that voltage until the generator was repaired, is that fine? Yeah, it's okay. First and foremost, I kind of go backwards here. If it disconnects from the loads and it's still at 48.4, it's fine to sit there for a little bit. Really not going to cause a big issue. I don't have a problem with that. As far as what SOC it might be at that point, hard to say, but very low. Depends on the load that was on the system, but you're probably sitting around 10%, somewhere around there, maybe even a little bit higher, a little bit lower. As far as if it's okay, yeah, it should be okay. Don't have a super, I mean, as long as your load's not like C/2, as it's going to hit that 48.8, you shouldn't have a problem with the low battery cutout. Oftentimes, I would suggest if you have a low battery cutout delay or hysteresis setting that you can change, so it changes how quickly the low battery cutout engages. If you're using a low battery cutout like 48.0 or 48.8, just set that trigger to go off quicker than you would want slower. So, 60 seconds versus 4 minutes, things like that. Would you and when recommend some type of battery warmer in low ambient temperatures? But you actually have some solutions there that can be used, in line with various thermostats and things like that to warm the batteries in those low temperature, as well as our SimpliPhi is a little bit more advanced with how it can function in low temperatures and ensure safety. So if you're interested, if you got a project specifically, just go ahead and shoot our sales or me an email, and we can provide you with that info on that, those temperature assist, basically. Can you send me the link for the IQ installer qualifications program? I'll tell marketing to put it in to the follow-up email that gets sent out so that you can find it. But if you're looking for it right now on the website, I'll tell you what, actually, I'll just see if I can do this real quick. All righty, here we go. All right, so SimpliPhiPower.com. So if we go under support and we go to IQ installer qualification program, You'll find everything from some swag you'll receive, the benefits here, the requirements listed here, and the application actually can be filled out right here and submitted to us. So definitely check that out if you have time, but I'll try to add that in as well. Okay, give me 1 second here. Let me fix this now. Okay, back to Q&A. There's my info again in case you need it. Okay, so how do you propose we initially charge a new battery? Good question. I used my array and minimal load draw and watch the number of amp hours net into the battery. Seems to work great. Yeah, great. That's a great way to do it. Basically, what we'd want to do is just make sure we're charging from the correct set points and do it before you put a heavy load on. You can really do it before you put no load on if you can avoid turning on the load at all on that first round of charging when you first get the battery, but as long as there's minimal load on, you should be okay. For larger systems, so 2 solar inverters, do you have a listed battery combiner you recommend? I've also installed all batteries to a common bus and then all inverters to that bus. Would you ever recommend batteries 1 through 6 to inverter 1 and batteries 7 through 12 to inverter 2? Definitely not the second question there. I don't ever recommend splitting up the batteries unless those inverters have different charging sources and different loads panels, or at least different outputs to different loads panels, or the same load panel. But they really, it's really good to combine everything. So combiner wise, Midnight combiner boxes are kind of my go-to. If you've got a really big system, look into our Boss cabinet. So our Boss cabinet can actually, we have a 6 and a 12 where we do a lot of the combining for you, or at least set it up so that you can get the bus bars to do the combining in the cabinet. And then you can either have 2 6s where you land them both on something, or you might have you know, a 12 where everything's nice and wired up, ready to go. As a residential homeowner and professional engineer, do I have to be SimpliPhi certified for the warranty coverage? So again, it is not a requirement to be certified. It's an added benefit to our installers. The only thing that voids your warranty is not following our instructions correctly and operating outside of the specs that the battery can handle. All right, looks like that was all of our questions came through here. So, you know, if you have any questions that come up after this, you know, please do not hesitate to reach out to training@simpliphipower.com or just call our support, call our pre-sales, say, hey, I just saw this presentation. I was curious about this set point, even maybe in one of my settings, you know, one of my installs. I'm concerned about a little bit of an oversized system. We can talk through it and work through the design. As always, appreciate everybody hopping on, and we'll be sending out some follow-up here probably sometime next week. Thank you, everyone.